Alright folks, let's dive into the wild world of multi-layer perceptrons. Trust me, they're like the secret sauce in large language models, revealing exactly where all that juicy knowledge gets stored in the neural network. It's like finding out where your roommate stashes the good snacks, essential for gaining deeper insights into how AI really ticks. Who knew a bunch of lines and dots could be so enlightening? Now, let's talk about vectors in high-dimensional space. Picture this. Each vector is like a highly intelligent, socially aware friend who can tackle complex topics, like discussing gender, using mathematical operations. It's almost as if different dimensions are like different sections of a library, each encoding a specific type of information. Just don't ask those vectors to organize your bookshelf, you might end up with a mess. On to transformers and their attention mechanisms. Think of them as the overachievers of context processing, while our trusty MLPs act like that friend who's always there to lend a hand with their storage capacity. Together, they create a dynamic duo, improving the model's predictive powers, almost like Batman and Robin, if Batman was a neural network and Robin was a multitasking genius. And then we have dot products coming in hot. These little mathematical gems tell us just how well vectors are hitting it off with specific meanings, like names and concepts. It's like your dating app algorithm, helping the model understand different tokens in input data, but hopefully with fewer awkward first dates. Every vector joins the party with a series of operations, all happening in parallel, which sounds fancier than it is, kinda like group projects. This approach simplifies how we comprehend how individual vectors change as they pass through the model. Instead of messy brainstorming sessions, it's like an efficient study group, everyone's on the same page. So how do we get these results? Through matrix multiplication with learned parameters. Just like a well-timed joke, biases refine the output values, giving the model that extra oomph to encode names accurately. It's like sprucing up your presentation with a few puns. Suddenly, it's way more engaging. Now, let's not forget the magic of the ReLU function. Like a bouncer at a club, it turns negative values away at the door while letting the positive ones through. This function is crucial for simplifying outputs in neural networks, helping to model those oh-so-complex relationships in data, like figuring out why your friend keeps responding with K when you text them. In the realm of transformers, neurons activate based on input values, behaving much like logical gates. Think of them as the brains behind the operation. This is essential for accurate data processing, highlighting just how vital activation functions are in the neural network party. Without them, it'd be an awkward silence. Don't overlook the powerhouse that is matrix multiplication. It's the glue that holds our neural networks together, influencing how features are combined and processed. This vital operation helps the network learn and represent complex data structures, like figuring out your friend's strange obsession with cat videos. Let's talk about embedding and unembedding processes. These are the unsung heroes, contributing significantly to the total parameters and hinting at a complex architecture that's essential for effective data representation. Think of it as the intricate design of a multi-layer burrito, where each layer has its own flavor of importance, delicious and functional. Now, the concept of superposition is a real brain teaser. It suggests that neurons aren't just simple features, they're like the overachieving students that want to represent multiple ideas at once, making everything a bit trickier to interpret. It shows us how features can overlap and influence each other, like the way your pizza toppings can sometimes lead to surprising new flavors. Finally, let's zoom out and consider those higher dimensional spaces. They allow us to store more independent ideas than dimensions, kinda like how your college life holds both your academic ambitions and your Netflix binge-watching schedules. This phenomenon is key for understanding how large language models scale up, giving them the power to tackle even the wildest of queries.